today we're going to base our lesson off of yesterday's, which was finding the area bounded between two curves. And we are going to slightly change one of the problems so that they work out better. I made this mistake here. So we'll go -2, and I'll be fine. And so you can, just attach yesterday's notes to today's notes. You're not going to get a new assignment today, but you will have an assignment tomorrow in class that you'll work on for the entire hour. Okay? So we will not take any notes tomorrow. You'll simply have a work day to work on this stuff. Okay? So, what? Sure, but it's your time, so it's your time. So however you use it, it's up to you. Okay. Yes. All right. So I have x to the fourth, boys and girls. The area bounded between x to the fourth and y equals 2x squared minus 1. What does x to the fourth look like? Yeah, it's a wider parabola. It's more flattened out on the bottom. And then 2x squared minus 1, it's a parabola that's shifted down 1 unit. Okay? Now the question is where they intersect. And what I'm going to use is I'm going to use my knowledge about their intersection through algebra to verify the graph. And so in order to find where these intersect, because we're not given any bounds, so I have to find the intersection points. I will take x to the fourth and set it equal to 2x squared minus 1. How would you solve that polynomial? X to the fourth minus 2x squared plus 1. X squared minus 1 times x squared minus 1. Do those factor? Yes. So what do you notice about your solutions? Yeah, it's a double. And if you have a double solution, that means that it touches tangent. So in this situation, 2x squared minus 1 is a parabola, and it's going to come up and just touch tangent onto the quartic graph. So it touches tangent here at 1, it touches tangent here at -1. And so the green will represent the area that we are trying to find. So what is the top function in this? What's the top function in this scenario? X to the fourth. What's the bottom function? So the integral will be from -1 to +1 of the top function minus the bottom function. Now, there's a trick here that can make things easier for you, and you can just solve it like that, that's fine, but I would encourage you to listen to this next piece. Do you see something interesting about this area? This area is symmetrical, right? And so, therefore, what I can do, very good. So what we're going to do is we are simply going to go from 0 to 1, and we will double the result. Why am I less likely to make a mistake here? 0 will just give me 0, so. Yep. So, 2 times x to the 5th over 5 Right. So I will plug in the 1, and I get 2 times the quantity, 1/5, minus 2/3, plus 1. Two times 1/5 can be rewritten as 3/15 minus 10/15 plus 15/15. So we get 2 times 3 minus 10 is -7, plus 15 is 8. 16/15. Okay, so look at your bounds here. I'm going from -1 to 1. And over that interval, the graph is symmetric. If I cut it right in half, it's the same on one side as it is the other. Okay, therefore, instead of going from -1 to 1, I can go from 0 to 1 and simply just double it. So that's a lot easier. All right, we're not going to be able to get through this problem before lunch, but we're going to need all the time we can in class today. So let's start this one as well. Area bounded between the curves y equals x to the third minus 3x squared plus 2x. I can find where this crosses the x-axis. 0 equals x times x squared minus 3x plus 2. Is that factor? X minus 1, x minus 2. So it crosses in 3 places. And 0, 1, 2. And then let's see where these intersect so we can, figure out kind of a bit more about the graph. Yes, yes. But let's actually find the intersection of these two graphs, okay? Might give us a better idea of how to draw it, okay? So x to the third minus 3x squared plus 2x is equal to 2x minus 2. What happens? Yep, the 2x's go away. X to the third minus 3x squared plus 2 is equal to 0. Does that factor? No, it doesn't. So if it's a cubic and it doesn't factor, how do we solve it? Good try. Pythagorean theorem would be right triangles. So quadratic formula. That's if it's squared. So this is P's and Q's. Thank you. We'll get to that when we get back. Okay. So my good friend Katie Apple, she was correct about this. She said, how do we solve that equation? We go to our P's and Q's. We use the rational roots theorem. And our good guess would be 1 or 2. And 1 works, doesn't it? So we guess 1. So we plug in 1, 1, -3, 0, and 2. So we know we have a solution of 1. That means that the graph crosses through at 1, doesn't it? Okay, that they intersect there. So I know my graph looks something like this. Okay, but so I have this intersection point of 1, but I need these other 2, and so does my remaining quadratic factor? No, so I'll use the quadratic formula. So maybe plug in your calculator quick. 1, -2, and -2. We get -0.73 and +2.73. So therefore, we really have these two areas, okay? And we could verify that these two areas are the same by talking about the symmetry of this graph at this point, because this is where it's the concavity changes. It's the inflection point. But if you didn't know that, you would really have to set up two. And so since we haven't done that, we're going to set up two integrals. And we have to identify the top function. And if you notice, the top function changes depending on where the area is, right? So if I were to draw a rectangle to use to find the area, you can see that this rectangle, the top is going to be the cubic, the bottom is going to be the line. If I draw a rectangle here, again, the top will now be the line and the bottom will be the cubic. So we'll have two integrals. The integral from negative 0.73 to 1. The top function is x to the third minus 3x squared plus 2x. And I'm going to subtract the line, which is 2x minus 2 dx. And I will add on then the area bounded between 1 and 2.73 of the top function, which is 2x minus 2, minus the bottom function, x to the third, minus 3x squared, plus 2x dx. So this is these are the bounds of integration in the integral that I set up to solve this problem. So we're going to make it just a little bit nicer here. Integral from negative 0.73 to 1. X to the third minus 3x squared. And then 2x minus 2x is 0. And then minus the negative 2 will be plus 2. Notice this is going to be the same as that, but different by a factor of negative 1. So let's, since negative 0.73 and 2.73, we'll obviously have to use our calculator for that, so we'll go into our table to evaluate those pieces. Let's just take the antiderivative here. So we have x to the fourth over 4 minus x to the third plus 2x. We're going to evaluate that at 1 and negative 0.73. Grab my calculator. And if I clear this out, y equals, and type in 0.25 x to the fourth minus x to the third plus 2x. And I'm going to go into my table so I can come up with values rather quickly. I'll type in 1 and negative 0.73. And you can see I get 1.25 and negative 1. So if you take 1.25 minus negative 1, you'll get, so that's that area, plus, now I just got to change the y equals to be a, so this is going to be a, it's going to be the same thing, just negative, right? Negative x to the fourth over 4 plus x to the third minus 2x evaluated at 2.73 and 1. So you could just change all that to negative. I'll insert a negative, make that positive, and make that minus. And we will evaluate at 2.73 and 1. You can see 2.73 gives me 1. Minus negative 1.25 is 2.25. So they are the same. And when we add those two together, we get what do you think? subtract the bottom from the top minus the bottom. Okay. We're going to switch this to 2x minus 2. What do you notice is different about this problem? An x equals. So is that a horizontal or vertical? Horizontal parabola. So instead of being a vertical parabola up and down, it's going to go to the right. Y squared is positive, so it goes to the right. If you notice, this does factor to x equals y times y minus 1. So we know it as not x-intercepts of 0 and 1, but rather y-intercepts of 0 and 1. So this is a really cool problem. I really like it. I'm hoping you guys do too. Sini, I don't want to call you out, but I sense you were sarcastic. Yep. Okay, and then 2x minus 2. So down 2 units, and then, over or up to over 1, up to over 1, so on and so forth. So it looks like this might be that one. Something like that. I will definitely have to find the intersection between the two, right? So how will you find the intersection between these two? Very good. Katie sees it. She's going to take what x is equal to and substitute it in there. So y is equal to 2 times y squared minus y minus 2. And I get subtract over the y, and I get 0 equals 2y squared minus 3y minus 2. And does it factor? So we have solutions of -1/2 and +2. Now, let's see who's really smart. -1/2, doesn't this look more like +1/2? Oh, wow, look who's very smart. We solve for y values, not for x values. So therefore, you can see that this is at -1/2, and this right here is at +2. Not drawn very well according to scale, but best we can do. Now, aren't we always used to using x values? So we could plug these in and find x values. However, this is the big moment, everybody. You got to watch this. If I put my marker here and I were to draw a rectangle, what would be the top? The parabola or the line? What would be the bottom? If I'm right here, the top would be the parabola and the bottom would be the line, correct? But if I move here, what's the top? And what's the bottom? That's a problem. You can't have the parabola be the top and the bottom. You'd be subtracting itself. So you may not draw vertical rectangles and integrate from horizontally. Instead, you must draw horizontal rectangles and integrate vertically. So you can see, you're good. Okay. So as I draw these rectangles, you can see that all the time, what is to the right and what is to the left? All the time, I have the line on the right and I have the parabola on the left. So therefore, I can stack these up all the way. All right? And so now I'm stacking them on top of each other vertically. So I'm going to integrate from a lower bound to an upper bound instead of a left to a right. That's the difference. Amber, you kind of gave a mean look there for a second. Okay. All right. So we'll try to put it all together right here. I have the integral, okay? And so instead of doing the top function minus the bottom function, we're going to do the right minus the left. So the line is on the right, correct? Minus the parabola is on the left. Why do you do top minus bottom? Because okay, all right, I will tell you this, okay? If you want to find the distance between 2 and -3, you would do right minus left. If you do left minus right, you're going to get a negative result, correct? So we're looking for length, so we'll do the right minus the left. All right, hey, I figured that out. All right, took me a long time. Okay, now, second of all, if you draw your rectangles horizontally like that, then what you have to do is instead of dx, this is dy. Right minus left. You can't do top here. Can't do top and bottom here. You have to do right minus left. So we're going to do dy. If you draw your rectangles horizontally like that, you're doing dy, okay? Then what I have to do is I have to have y values for here, for my bounds. Do I know the y value? -1/2 and +2. Very good. Now, I also have to make sure that all these variables have a y in it. Yep, so this says y equals 2x minus 2. I'm going to rewrite it so that it's, yep, add the 2. So I got 2 plus y is equal to 2x. Divide by 2. We get 1 plus y over 2 is equal to x. So now I have the variables in terms of y. So let us integrate -1/2 to 2 of 1 plus 1/2 y minus y squared minus y. Oh. Okay. Can I combine any terms? Yep, 1/2 y minus the negative y will be 3/2 y. So I have 1 plus 3/2 y minus y squared dy. What's the antiderivative? Y. Yep, 3/4 y squared minus. Evaluated at. Oh boy. Okay, plug in 2. Plus 2 squared is 4. Cancels out the 4, so I got 3. Minus 8/3. Minus -1/2. What's -1/2 squared? Times 3/4 will be 3/16. A half squared, or half to the third, 1/8 divided by 3 would be 1/24. But it's negative, so it will be what's my common denominator going to be? 24. Yep. So this will be 5 multiplied by 24 is 120 over 24 minus top and bottom by 8. I've got 64 over 24 plus top and bottom by 12. I get 12 over 24 minus, oh, it wasn't 24, it was 48, wasn't it? Sorry, 240 over 48 minus 128 over 48 plus 24 over 48 minus 9 over 48 minus 2 over 48 because I have to distribute the negative. Oh, there we go. 240 minus 128. When you cube the negative 1/2, it's negative. Negative makes positive. So 240 minus 128 is 112. Plus 24 is 136. Minus 9 is 127. Minus 2. Perfect. One second. What's that? It's really hard to check the original. You can check like from, here on out, but yeah. Okay, last thing I want to show you guys. Okay, before you go, just watch. This is super important. This is the big idea. As I drew this rectangle, okay, as I examine the width of this rectangle, I'm going to say that this width is dx because is the width horizontal or is it vertical? It's horizontal. So when you draw your rectangle, you can tell you have horizontal width, dx. Look at the last one we did. Do these rectangles have horizontal width or vertical width? So dy is my width. So when you draw your rectangles, you tell right away whether it's going to be an x or a y. Perfect. Tomorrow, I create an excellent worksheet for you to do that will put all of your learning in a good place, and you'll feel so great about area between two curves.